Okay, so today, with just the symbol ball right here, I am actually going to show you how easy it is to understand space. Yes, the things that we look out there every day and every night, it is actually really easy to understand. And I am surprised that no one in the world actually would teach this method. If they have done this method in school, a lot of people would have understand how space actually works. And the basic principle of that, it's really easy. And if you are a science teacher, you may want to look into this, how I presented this video, and then teach your children or your students with it, and they will understand space a lot better. All you need is a can, some rubber bands, see, a can, a big can, some rubber bands, and a ball, and a t-shirt. That's it. And you will be able to mimic space and how space actually works. Now, since I got out of the way, oh boy, before I go further, I wish they taught me this in kindergarten. I would have known a lot of stuff by now, but hey, I guess I have to be the one that actually would teach this type of models, okay? But if you see this video, and if any of the kids that doesn't understand space, please show them this video, because it will open up their mind a little bit. Okay, now I'm going to zoom in a little bit, and we're going to start. Okay, imagine this is what space is, but in 3Ds, okay? Meaning everything, okay? And that's why they call space, it's like a fabric. But it's actually not. Space will take over. So let's say, if I go out in space with a ball, eventually, if this ball has nothing in it, it will squeeze everything into a thing, into like flat. That's because space is compressed. Sort of like when you go down in the water. When you go down in the water, what does it do? It compresses. If you take a ball and bring it down into the water deep enough, that ball eventually will get crushed because of pressure. Now, this is why space is so good. And believe it or not, we can say space is so good. Okay? Sorry about the bear, my battery ran out. Now, let's get back to here. I stated before how space works so good and so well. If you take this principle, what I show you here, you will understand why space works so good and works so well. Okay? Now, I want to set it up so you guys can see on the camera there. If you take, for example, a sun or the earth, doesn't matter. Okay? The earth works a little bit different than the sun, as you already know. The sun pumps out energy. The sun pumps out light. To light, space, because space is dark. Space is nothing. But space is something, because I'm going to show you. And I actually have a video up here talking about space is something. Okay? Now imagine this is 3D. Right now we're seeing it in 2Ds. We have to think as 3D. Let's say this is the Earth. Just an object. Doesn't have to be the Earth or anything. Just an object. Okay? And it drops into space. You see how space is bent a little bit? Now look at this. If this is really heavy, heavier than space, look what happened. It sink down. And you see how that works. It sink down. Okay? I'm gonna zoom in just a little bit more. So the lighter the object, the lighter the sink. If this object is really heavy, look what happened. It warped the space around it. See it? So if this object is light, then space will take over. This is where I come in and take over that space. So if this object is really heavy and it's in space, look what happened. But if this object is light, space will take over and it'll come back. You cannot warp that much. You see that? Now, step 2. And this is where this thing comes in hand. Until people understand space, then they know how things move in space. Okay? We call it move or travel in space. If there is no motion, the object will stay stabilized. If you gave it a push, because we're on Earth, it stops because gravity. Okay? But in space, here's how it happens. And this is where I come in to teach you this. The space, as you saw a little bit earlier, space warped because of the object. How heavy the object is. So it warped that space. If the object is light, then it's light. If the object is heavy, then it warped more space. Okay? Remember that word, warp. Okay? So if you got a really heavy ball, it will warp the space. Now if you push that, as it goes, it warped other space. If this is a large scale, it will go on forever. And this is how it will go on forever. Imagine, I have the ball here. If space takes over, the ball would move. Wherever that direction is. Okay? So if space is here, if it's here, and imagine when you push that ball, it warped the space, and look, it will follow me. You see that? So anytime space warped, look, see the concept? That ball would follow me forever. Because once I apply the energy, that ball will follow. But because in space it's so vast, it keeps going forever. See? I didn't touch the ball's following me. So if you pushed it, the space around here will get warped. And when it get warped, it'll move forever. You will need no extra energy. Because space, if you notice, if I push here, that ball comes to here. If I let go, space takes over. And see how space takes over. Okay? So when it's heavy, the heavier the object, the deeper the sink. You see that? Okay? But if you pushed it, it will follow. So if this was space, like really big, 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 just like out there, it will go on forever. See? I didn't touch it. It's following me. See? Because we are warping the space. So literally, when you push this ball, space becomes warped. And as it warped, it will move. But here's the thing. That warped of energy move on and on and on and on and on and on and on. So it create sort of like free energy until it hits something, of course. Here's the thing. Now, sorry, I have to step away a little bit. Here's the thing. What if there's another object? This is where the interesting part will come in. This here can actually influence that. Yes. Look at the moon and the earth. If this was the earth and it moves around, look what happened. It influenced that ball, even though I'm not touching it. You see that? And that's how the moon and the earth, that's why the moon wobbles a little bit. And by the moon wobbling a little bit, we have our ocean shifted. So they actually influence one the other because of the warp in space. Get it? So if there's a bigger warp, you will see more wobbling. If it's less warp, then you see less wobbling. Get it? Because you have to remember, everything has to be equal. But because of space, because of the help of space, thank you, thank you, space, the influences that you can see, this actually does it with the sun as well. The sun actually wobble around space. Yes. If you look at far enough, you will see the sun actually wobble a little bit. If you are far away, you'll be able to see this phenomenon. We're too close. We won't see it's wobbling. But also, wobbling, it's by, look, just enough. Because the sun, all the object around that, like all the planets around that, affecting the sun's wobbling. Because look right here. I just tapped a little bit and look. You see the wobbling? See it? Oop, too much. See? It bounced up and down. Because if this was going around, it's going to affect the sun. Because we're moving around. And by moving around, we're affecting the sun. But because we're so close to the sun, we aren't able to see this phenomenon. If you were far away, the farther you are, the more the wobble you will see. So right now, we have about 7 planets. If you calculate all those planets, you will know exactly how much of the wobbling of the sun really is. Because all the object, it's influencing the sun because of space. This is our fabric of space. Because space stretch. Because this sun is dropped into the center of it. So it's actually wobbling because we are influencing the fabric of space. Get it? So all the object, it's influence the space. So they make it like a ripple. It's like a wave. That's another thing too. I actually discover how to make space ripple on Earth for you guys. I actually played with soap one day, and I left it there, and I actually see how things actually work in space. I will make that video later to teach you guys. No one in human history teaching how space actually warple either. Not warple, but space, they called it wave and movement. You can actually see. They tried, but they couldn't figure it out. Can you imagine? Just maybe $2 worth of soap can actually mimic, I don't know, a $25 million study. Yes. Can you imagine? They spend 25, 30, 50 million, or even in billions to try something that I developed or discovered how things actually work. It's space ripple. And I'll do that video and teach you guys that later. But it's only like $2 worth of soap. Can you imagine? They spend millions and millions and millions of billions of dollars trying to see space ripple. Okay? But all they need is about $3, $2 worth, $2, $3 worth of soap, and they will know how actually space ripple, okay, works. But anyway, that's another video there. But this video is about space. But I just find it funny that actually it takes them millions and millions of years, dollars, or even billions of dollars to learn something. It's actually, we can learn for free. Sort of like here. We're learning for free right here. But like I said earlier, they don't teach these in school. And I think that's why if they have something like this in school, a lot of kids would understand how space actually works. And if this was a fabric in space like this, it's all like that, because you remember, space will try to take over. If there's a hole here, space will take over. If there's a hole here, space will take over. Oh, also too, I'm going to teach you actually how black holes actually works. Similar to this, but I don't want to go into that because it's a little explaining to do. I can tell you right now, they do not understand black hole. But if you understand space, like I show you here, you too will understand black holes. Yes. Yes. You heard it correctly. If you understand space this way, you will understand black holes. That's another video there. Now, let's get back here. So you understand the influence of space. If this object was heavy, it will steal. Let's say there's two here, but this one is heavier. Whoops, sorry. If this one was heavier, look what happened. He'll steal that object. Okay? Now, here's a question. Why does the moon and the sun, the moon and the earth does not go like that? Why didn't it go like this? Here's the reason. Because they're both magnetic. So there's an invisible magnet here, which we never taught either. We were never taught that either. And that's why when the earth moves, the moon moves around it because of the magnets. So we know that the earth have a magnet which pulls North Pole and South Pole. That means the moon also have a magnet, or else this would happen. They would crash. Okay? So far, we know that the earth and the moon, they both are magnetic. They've been stabilized, meaning they are set into a zone that they cannot come to each other. It's due to weight, and it's also due to magnetic field. And we heard this all the time. If the earth was actually heavier than it is, the moon would be like this. the Earth would steal the moon. Yup. So thank you to the moon that is not big enough, or it's not heavy enough to capture fully. Okay? So that's why the moon is stuck there now, and it's been stabilized, because both of these stabilizing each other. Now here's the thing. And that's why the moon have its own gravity, but it's smaller than the Earth, because it's not alive. Okay? During the making of our solar system, the moon actually have its own gravity. Everything have its own gravity. Why? Who gave it? Who gave it to him? The sun. I'll go into that in another video. It's going to be a longer, but I'll go into that video. So that's why if you saw landing on the moon or anything, people are jump higher on the moon than on Earth. Why is that? It's because it has less gravity out there. And also, it doesn't have an atmosphere. So, space and the moon actually contribute to you jumping. Okay? Please remember that. What we were taught in school is actually wrong. Gravity in the moon. They did not figure that space, which is this subject, contribute to that. Okay? So they didn't really figure that one out. But someday they will figure out why we actually jump higher in the moon. Space actually help you on that. Not just gravity alone, okay? Please remember that. Because I just gave you an example. If Earth had more weight and more gravitational pull, it would do something like this right here. Okay? It will steal the moon. And then someday both will crash into each other, and then they become one. Okay? That's how that works. But because the moon have its own gravity, the Earth have its own gravity, but not enough to steal it, because you have to bend space more. Because if it's heavy enough, it will bend the space. And eventually, because of that influence, the moon would automatically draw to the Earth. But because the Earth is not heavy enough to bend that space, so the moon is stationary. And the moon have its own bending space. So literally you would see something like this. You see that? And there's a curve right here in the center, which you cannot see. But if you do that, the same thing, you will be able to see the curve right here if you press both down. So that way they can't come to each other, and this one cannot come to each other. Get it? Unless this is enough that is able to pull it. Get that? And that's why the moon and the Earth cannot come to each other, because there's a ripple here. There's a hill there. Because this influence certain amount of space, and this influence a certain amount, and they cannot come to each other. And when they go around each other, they actually wobble because of that, because of the fabric of space. And that's the easiest way I can explain space, and the easiest way to understand space. If they have take this fabric and do what I did here, I'm going to spin it out a little bit because I'm going to end this video. If they have done that, students around the world, kids around the world would understand this, how easy it is to understand space. Just by two objects alone in space, you will understand how space actually works. And yes, thank you, whoever it is to invent space. Because without that, everything would, it wouldn't be the way it is. And yes, it's a very actually good concept, whoever invented space. He, she, it, blah blah blah, whoever it is. Thank you. I have to say thank you. But that's how it works. And that's how easy it is. And if they take this concept and teach this in school, a lot of kids will understand better about how space actually works. And remember, this is only 2D. We have to make it into 3D. That means everything, this fabric covers everything. Yup. 360 degree, this fabric will be all over the place. We're just suspended in space, just like how they talk about it. We all suspended in space. The moon, the earth, the sun, everything. Even our universe, it's suspended in space, okay? And that's how it works. And I hope by watching this video, you would go into an understanding, a very easy and then very easy concept of understanding space. And and like I said, and I'll say it one more time, I wish they teach this in school, because a lot of kids would understand space better. Anyway, I hope you enjoy this video, and I hope it is educational, and I hope that you will understand and open your world a little bit, and you will see things actually fit very nicely in this whole universe. Just as simple as this right here. Anyway, I will see you in the next video. Okay?